All right, so I am Stephen Hillion. I am the product guy for Alpine Data Labs, and before that, I was running the analytics group for Greenplum, and part of that was to hire a data scientist team. And that was not a particularly easy thing to do, even in the heart of Silicon Valley, where I think there's been a great deal of innovation in data science, especially in internet companies. There is hot demand for data scientists. There are very few university courses in data science, and so it can be difficult to hire these people, and finding them to build that team, which is now of a decent size. There are probably about 15 data scientists just at headquarters alone in San Mateo in California, was not an easy thing to do. And so I'd like to offer some tips and advice for that, and probably come to the conclusion that the way I did it was probably not the best way, and maybe make a couple of alternative suggestions for how to go about hiring a team of data scientists. And I should qualify what I mean by that. I'm talking not necessarily about, say, BI experts, important as they are, the people who will, say, create and use dashboards and reports for generating analytic information and analytics insights for the rest of the organization. I'm really talking about data scientists who are investigating, exploring data, using more advanced techniques, statistics, predictive models, and so on, in order to tease value out of data that isn't already present in it through simple aggregates. That's really what I'm talking about. So how do you find these folks? The first thing you need is a mathematician. This is Emmy Noether, in case you don't recognize her, a great mathematician around the end of the 19th century. Invented Noetherian rings, or found them, depending on your point of view. So that's what you need first of all. You need a mathematician, statistician, somebody who understands numbers and recognizing patterns and all the stuff that Marcus was talking about earlier. The second thing is you need somebody who can actually write code. And I would say that right now the conventional wisdom is that you need this sort of hacker mentality. You just need to be able to do what it takes to write some code to get the value out of the data, whether that's Java code or some Python scripts or SQL, or whatever it might be. So there's Donald Knuth there, one of the great software engineers of the world, one of the great computer scientists, and so that's the second talent that you need in your data scientist. The third thing is you need Angela Lansbury to act as something of a sleuth. This ability to explore the data, to tease insights out, to iterate, to go and investigate things that you just don't know are there in the first place. In that sense, data science is a little different from software engineering generally, in that you don't really know what you're going to find until you start looking. So those sort of sleuth-like qualities. The next thing you need is sort of artistic capabilities, storytelling, the ability to make the data live, to be able to use visualization and other means to let the data express itself. And also to tell stories to your end users so that you can make the data come alive and make it actionable. And then finally, and unfortunately there are no famous business analysts. If you Google business analyst, you'll get a bunch of Dilbert cartoons and some ridiculously cliched stock photos from websites. And so that's what I've chosen. And there's the business analyst. And she's typically going to act as the intermediary between the business and the IT group to understand what the requirements are. You need that person as well. You need to be able to understand the domain. You don't, if you're going to be doing a pricing elasticity study, need to be constantly explaining to your data scientist what ACV means or TPR. You need to have that stuff under your belt. You don't need to be the expert on the business, but you need to be able to know how to talk the language. So you need some domain expertise. So you put all these folks together, the artist, the software engineer, the mathematician, the sleuth, and the business analyst, and the intersection of those is there. And there's about 2 of those people, and I've already hired them, so I'm afraid that strategy doesn't really work. And I think the conventional wisdom, or the sort of the workaround for that, is that you sort of hire physicists. Not that I'm saying that physicists firmly sit in that intersection, but they're sort of like, 2 or 3 out of 5 ain't bad. They're pretty good about doing mathematics, not great, but they're pretty good at mathematics. They understand how to apply models to the real world. They have some understanding of the real world, unlike the mathematicians, so you have some of that sort of business acumen. And they've probably written some code, so they sort of have some of those software skills. So that's not a bad way of doing it. That's typically how the finance industry has done it. They've hired physicists and biostatisticians and these people who understand how to apply mathematics to real-world problems. Problem is, those folks are fairly few and far between, really. And secondly, as I said, they've already been hired by finance, so that's not going to work. But that was pretty much how I went about doing it with the data science team at Greenplum, is looking to local universities, local people who had come out of fields like physics and biology and mathematics and economics, and maybe had some experience of working with business, and those are the folks that I hired. If you look at the data scientist team at Greenplum, you'll see graduates and undergraduates from economics majors, from bioinformatics, from mathematics, from mining, from operations research, and so on. But here's another approach, is maybe to try and start to simplify things a little bit. So first of all, I'll let you into a little secret. As somebody who's worked with data science for a little time now and has built models for large companies, it's not really that difficult. We need to demystify data science a little bit. It tends to be the same techniques applied over and over again. They're tried and tested. They're not actually all that new. They've been used by companies like Procter & Gamble for decades to do things like marketing studies and campaign optimization and pricing optimization and sales forecasts and so on. Things like time series and regression analysis and clustering techniques and so on are well known. The mathematics behind them may be reasonably complicated, but the application of them is really quite standard. So I think through a combination of training and tools, you should be able to demystify this stuff a little bit. Secondly, this whole ability to sort of explore the data and tease out insights and be iterative to sleuth your way through the data is made a lot easier if you actually take some lessons from the software movement, most recently, agile tools and processes. So if you have tools that allow you very easily to get into your data, and this is really where we're focused at Alpine, by using in-database and Hadoop techniques to bring the processing to where the data is, then it allows you to have a much more agile, iterative, less cumbersome approach to doing analytics. So if you apply those sorts of tools with the agile software methodology, where instead of going for 6 months on a long-term project with a single goal, you sort of iterate on that and you learn from what you find along the way, then I think that can simplify things a little bit as well. The next thing to do, well, I don't know what you do about artistic capabilities. That's something maybe you either have or you don't have, or I would suggest that it's something that you can learn and you read Edward Tufte. So that would be my approach there. That leaves you then with the business analyst and the software engineer. And I think if I had to hire more data scientists right now, and at Alpine we are hiring, so let me know if you're interested, one approach that I might take is to focus on the software engineer and the business analyst. You can't really get away with doing data science without these folks. You need an understanding of the business, and I don't think you can rely on the software engineer just to learn it ab initio. And you need somebody who can write code, at least I think you do, in order to generate the statistics and the analytics. So I think you need these folks, and therefore the strategy would be to start with something that looks very much like a traditional software engineering team. Software engineers who are generally going to be smart enough that they can understand the mathematics and can go off and learn about it and get trained, and at the same time have that discipline, and actually maybe reduce a little bit that hacker mentality, because one of the things I've noticed with data science teams is because you've typically hired folks with perhaps a little bit more of a mathematical bent rather than a traditional software training, you tend to get code that's not very well written, that's not very reproducible, that doesn't reuse common libraries and so on and best practices, and therefore is sort of thrown over the wall into the production environment, and therefore you have a little bit of a battle between the data scientists and the rest of the IT group. So maybe introducing some of the discipline of software development would actually be a good thing. So starting with your software engineers and business analysts, make sure they have good iterative tools that bring them closer to the data, and great training on the mathematical techniques and statistics. And then I would also recommend using agile practices, as I said earlier, to iterate more to get towards your results. That's not a bad way of going about it. It would sure be great if the software engineers came in pre-trained on the techniques of big data and data mining, and that's where I think we have to wait for academia to catch up a little bit. I don't know really what the situation is like here in the UK. In the US, some universities are starting up academic programs around data science. The University of North Carolina, for example, in association with SAS, has set up an Institute of Data Mining and Institute of Analytics, which is doing very well. And Northwestern University also has a master's in analytics, which I know is very well subscribed. I was meeting last week with one of Alpine's advisors, Yuri Leskovich, who's a professor at Stanford. And he runs a course in, I think it's big data and data mining. It's a graduate program, and it has 285 graduate students that show up every week. I've never known of a graduate program that can attract that number of students, and I think that shows you how keen people are to learn about this stuff and to place a bet on big data in the future. But here's a final thought. What if you didn't have to write code? What if you simplified this to such a degree that you took those classic data mining techniques and you made them accessible to the business analyst? At Alpine, we talk about the rise of the MBA, the smart, data-savvy, numerically sophisticated business user or business analyst who aspires to be a data scientist but doesn't necessarily have the formal mathematical training or the software engineering skills. What if you could create software that allowed you to do sales forecasting and churn models and customer segmentation as easily as you could throw a pivot table into Excel? Well, that's what we're focused on at Alpine Data Labs, and I don't think that's too far away. Okay, thanks very much.